A little bit more to the right.
There we go.
I don't even think this beam is going to hit our boat. We're going to have to measure it on something else. All right.
No idea.
Here we go.
Is that your measuring tool?
Do you see it?
Yep.
Can you mark it?
We made the second measurement. My whole world fell apart. It's like 6 feet.
Yeah.
Yeah.
It seems a lot higher.
Okay.
You got it?
Huh?
Really?
Just 3 miles away, the laser seems to have risen by 6 feet. But we know the beam is level, so that suggests that the lake is now 6 feet lower.
To see a 6-foot drop when everything looked flat to me was kind of mind-boggling. Definitely kind of shattered my perspective in about 1 second and made me rethink what was going on. Perception is still it's a flat lake, but
It's not a flat lake.
it's not a flat lake.
That was crazy. I was definitely blown away by the fact that the laser was that high off the water.
Hey!
Hey, Joy.
What's up?
We're back. So how was it?
The laser was 6 feet up in the air, and we had to use this board to mark it. It was cool.
The lake is clearly not flat. It's almost as if it's sloping downhill. With this realization, my volunteers have made their first step towards measuring the entire world.
I think we should make some more measurements for sure.
Yeah, agreed.
Yeah, totally.
But they are not the first people to do it, of course. In fact, the first person to measure the Earth accurately was an ancient Greek genius named Eratosthenes.
More than 2,000 years ago, Eratosthenes, a very clever philosopher, mathematician, geometer from Greece, he embarked in an experiment to measure the diameter of the Earth. If the Earth was flat, anywhere on the flat Earth, at a given time during the day, we would see the sun shining with the same angle. While if it is round, that won't be the case.
Eratosthenes had heard that at noon on the longest day of the year, the sun shines directly down the water well in what is now the city of Aswan in Egypt. Here, the sun must be directly overhead. So in another location, 500 miles to the north, he made a second observation, again at noon on the longest day of the year.
Here, 500 miles north, he performed this experiment and he planted a pole vertical and realized that the pole was casting a shadow.
The shadow was evidence that the sun is not overhead, but at an angle. By measuring this angle, and knowing the distance between the two locations, he was able to calculate that the Earth is a ball, about 8,000 miles in diameter. But the question is, with the right tools, can the volunteers match this ancient genius?
Today, we'll use lasers and GPS and all kinds of technology to come more or less to the same number. This is what science is about. It's about inventing new ways of investigating nature, looking for facts, looking for measurements, and come with results which are astonishing.
My volunteers have discovered the lake is not flat, but in order to measure the whole world, they need to make a new measurement much further away. And to do that, they will need some new tools.
Okay, let's get this box open.
Alright.
Yeah.
Alright, what do we have here?
Like a tripod.
Now, instead of a laser, a telescope will enable our volunteers to look in a straight line to the lake's opposite shore. But that's not the only instrument they'll need.
We're wondering, okay, how are we going to get this next point if it's so high it's past our board?
Whoa!
Very cool.
Are we getting in a helicopter?
This chopper appears out of nowhere. Alright, that is awesome.
Just as the telescope replaces the laser, the helicopter takes the place of the boat.
I'll stay with the telescope.
Okay, great.
We'll go in the helicopter.
That's planned.
Sounds like a plan.
Yeah.
Alright, let's do it.
All right, we'll go ahead and lift off.
I love that there are no doors. We're flying to Pyramid Rock. Do you copy that?
I copy that. You are flying to the pyramid.
The lake looks completely flat from up here.
If they are twice as far away as before, how much lower will the far shore of the lake appear to be?
Jib, we're going to be at the top of the Pyramid Rock.
Oh, got him. Yeah, I have you on the telescope. Go ahead and land. As it lands, it completely disappears from my line of sight. Joe, are you still airborne?
Yeah. Can you see us landing?
The reports from the helicopter, they're still flying. But I can't see it. To wrap your head around it in that short of time was a little difficult for me. I was like, this is crazy.
We have landed in our position.
Okay, Joey, go ahead and lift off.
They plan to ascend until Tim can see them on the horizon. Then they'll tell him their altitude.
Let me know when you can see us on spots of the horizon.
I got him. Okay, what's your elevation right now?
Alright, Brian, how many feet are we above the lake?
24 feet.
Woo! We've made it! 24 feet.
24 feet, awesome.
24 feet is a lot higher than our other 2 points that we got. That was awesome. It was great.
At 6 miles, the lake has fallen 4 times lower than before. So what is going on?
Okay, you guys, check this out. So, if this line is our laser beam
Right.
that we shot across the lake, right? And that's the shore. This is the laser, right there. And we join our data points at 6 feet, and then all the way out to 24. This is our source. That's our flat line, right? And this is the surface of the lake.
The green line shows the path of the laser and the view from the telescope. And the gold line shows how the data points form the beginning of the curve.
So that means this lake isn't flat.
It's not even close.
No.
It's crazy. If we can just continue that curvature all the way around, complete a circle, and we can measure it, then that gives us the circumference of the Earth.
With these measurements on the lake, we can calculate that the Earth's circumference is around 25,000 miles, which matches Eratosthenes' calculation.
I still have a hard time wrapping my head around the fact that we measured the Earth at that lake.
I'll never look at a lake the same way. I'll never look at a big body of water the same way now that I know it's following the curvature of the Earth.
the shape and size of the Earth is just the beginning of finding out where we are. To learn more, we need to journey into space.